The topic is areas between two curves. So let's do this example. Find the area of the region in the first quadrant that is bounded above by y equals square root of x and below by the x-axis and the line y equal x negative 2. So first thing we need to do is find the point of intersection so we can graph both functions. So what we do, we set both y's equal to each other, right? You set this equal to this. So square root of x is equal to x minus 2, and then you try to solve for x. I mean, or you could solve for y, for x, and then set the x's equal to each other. But let's do it this way. How do we solve this? We square both sides. Now we have x is equal, therefore x is equal, we fold that, we get x squared minus 2 times x times 2 minus 4x plus 2 squared, which is 4. Now move everything to one side. So this means x squared minus 4x plus 4 minus x is equal to 0, which means x squared minus 4x. So x squared minus 5x plus 4 is 0. So let's factor this. If you factor it, it's going to give you x minus 1. X minus 4 is 0, which means x is equal 1 or x is equal 4. You need to watch out for this when you're solving, because remember we're solving this equation, square root of x is equal x minus 2, and then we square it here, right? When you're solving a radical equation, you always want to check your solution. So check x equal 1. How do you check it? Plug it in. If you plug it in, you get square root of 1 is equal 1 minus 2. 1 is equal negative 1, so it's wrong. So then you throw it away. So this is going to be thrown away. We call it extraneous solution. Now check x equal 4. If you plug it in, you get square root of 4 is equal 4 minus 2, which is 2 equal 2, so it's okay. So x equal 4, we know x is equal 4 is the x coordinate of a point of intersection. Since x is equal 4, now how do we find the y value? Plug it in here, right? Or in this one, doesn't matter. So y is equal square root of 4, which is 2. So one point of intersection is 4, 2. Alright, another way of doing intersection, I don't want to confuse you, but I want to show you everything you need to know. Another way of finding the intersection, you can find the y coordinate. Since we're going to use f of y minus g of y, you'll see why. So another way you could solve y equal square root of x, means solve for x. This means x equal y squared. We're going to need this anyway. You'll see what I'm talking about. And then y equal x minus 2. If you solve for x, you'll get x equal y plus 2. Right? In other words, these curves are exactly the same. Right? Except they're written differently. They're written here as a function of y instead of function of x. Alright, and then you said the x is equal. This means if you said the x's equal to each other, you get y squared equal y plus 2, which means y squared minus y minus 2 is 0. Factor the y, you'll get y plus 1, y minus 2 is 0. Which means y equal negative 1 or y equal 2, but y equal negative 1 is below x-axis, so we don't need this, so we need only y equal 2, which means x equal y squared, 2 squared, 4, so we get the same point, 4, 2. So let's go here, here's 4, 2, right here. Now I know that y equals square root of x is going to look like this. right? Let me keep continue. We don't care. We need to find the y-intercept to graph y equal x negative 2. To find y-intercept means we're looking for when is y equal 0, which means x equal 2. That's x-intercept, right? Why do we need x-intercept? Because we know it's a line, because we're only interested on the region above x-axis. So x equal 2. So we're only interested on this line and this segment of the line. So this is the region, right? So it'd be easier to use, because if you look at it, there's a curve that's on the right and a curve on the left. So here's the definition. Definition said if f is the right-hand curve and g is the left-hand curve, then the area is going to go from y equals c to d. So y equals c, which means y equals 0, to this number y equals d. Remember this point of intersection, we said it's what? 4, 2. This point is 4, 2, which means this is 4. So now we know that the area is going to be the integral that goes from 0 to 4. And then we need f of y. We need this function, the one that's on the right side, which is x equal y plus 2. Remember we solved for x. So y plus 2, this is what we mean with f of y, minus the left one. And in this case, this is y equals square root of x. If we solve for x, we get x equal y squared. So minus y squared dy. Right, and this is pretty easy. This is going to be, if you take the integral of y, it will be y squared over 2 plus 2y minus y cubed over 3. And we want to do this between 0 and 4. And if we plug it in, we'll get 4 over 2 plus 4 minus 8 over 3, of course minus 0, which is going to be equal 10 over 3. Now what we're going to do, we're going to try to do the same problem and show you why this is the best way to do this problem. But we could have done this using this formula, this definition. A is equal integral from x equal a to x equal b of f of x minus g of x dx. So let's graph it. Remember this, the graph is what? 2, 4. We know that this number is 2, and here this is 2. So we got So if we want to use this definition, what we do, I'm going to just split this area in 2. And let's call this A1 and then A2. So we both agree that A is going to be equal A1 plus A2, right? So A is equal, but what is the area of A1? We could have, this is y equals square root of x. So it's the same thing as integral from here to here. So from 0 to 2 of square root of x dx minus a 0, which is square root of x dx, plus, and then a2 will be integral from 2 to 4 of y equals square root of x, right? The square root, so it's square root of x minus, and then the function that's below, which is y equal x minus 2, so minus x minus 2 dx. So if we do this, we will still get the same answer, except this is a little bit more work. So this is x 1/2 from 0 to 2 plus, and this is x 1/2 minus x will be 2 over 2, and then plus 2 means plus 2x, and this is between 2 and 4. And I mean, if you plug everything in, this is going to be 2 to 1 half minus 0, right? We don't need a 0 plus. And this is plug in the 4. 1 half minus 4 squared over 2 plus 2 times 4. All of this minus plug the 2 to 1 half minus 2 squared over 2 plus 2 times 2. And if you use your calculator, you're going to get the same thing, which is 10 over 3. So there are two ways of doing the same problem. So you could treat the two graphs as y equal f of x or x equal f of y. And in this case, it's easier to do it the first way. Alright, that's it for this problem.